Hello students, today I will be taking aldehydes, ketones and carboxylic acids, organic compound containing oxygen, one of the very important chapter for all level of examinations. So aldehydes, ketones are the compounds which contains carbonyl group. They are also called as carbonyl compounds. So aldehydes are represented by RCHO or RCOH. Ketones RCO R dash or RC carbon to oxygen double bond and R dash. So about the structure of carbonyl group. So carbon atom involved in the carbonyl group, it undergo sp2 hybridization. sp2 hybridization. The bond angle that is equals to 120 degree. Since oxygen is more electronegative, oxygen acquires partial negative charge and carbon acquires partial positive charge. So here oxygen contains two lone pair of electrons. This pair of electrons shifted towards the oxygen. So oxygen, it acquires negative charge and carbon acquires positive charge. So partial negative charge and partial positive charge. So this leads to polarity in the molecule. Now, it's about the preparation of aldehydes and ketones. Then we'll move on to isomerism in aldehydes and ketones. Now, it's about preparation of aldehydes and ketones. Preparation. First one, starting from alcohols by oxidation. From alcohols by oxidation. So when primary alcohols oxidized with oxidizing agent like pyridinium chlorochromate, PCC, pyridinium chlorochromate. So alcoholic group undergoes oxidation to give aldehyde. Now, similarly, secondary alcohol are CH, OH, R dash. On oxidation in presence of anhydride of chromic acid, CrO3, it is oxidized to ketone. Okay. So this is from alcohols by oxidation. Now, next method, by dehydrogenation process. By dehydrogenation process. So when primary alcohols pass through heated copper at high temperature, so vapors of primary alcohol, when passed over heated copper, it undergoes dehydrogenation to give aldehyde. Similarly, when vapors of secondary alcohol is passed over heated copper, okay, it gives ketone. Ketone is formed. Okay. So this is about conversion of alcohols to aldehydes and ketones. Aldehydes and ketones. Now, next method. Next method. From acid chloride. From acid chloride. So in the preparation of aldehydes, acid chloride is subject to reduction in presence of Lindlar's catalyst. That method is called as Rosenmund's reduction. Rosenmund's reduction. Or COCl, acid chloride. When reduced with hydrogen in presence of Lindlar's catalyst, it gives aldehyde, RCHO, aldehyde is formed. Okay. So this reaction is called as Rosenmund's reduction. So if you take acetyl chloride, it gives acetaldehyde. Benzoyl chloride, that gives benzaldehyde. Now, aldehyde is formed. Now, next, in the preparation of ketones, when acid chloride is treated with dialkyl cadmium, okay, it gives ketone or CO R dash, ketone is formed. Byproduct is cadmium chloride, Okay. This is about preparation of aldehydes and ketones from acid chlorides. Next, about from alkynes. Okay. When alkynes subjected to addition reaction with water in presence of mercury catalyst and sulfuric acid, acidic medium, dilute sulfuric acid, from alkynes. In this reaction, if you take acetylene, ethine, that gives aldehyde. Other than acetylene, any alkyne on hydration, that gives ketone. First, we'll take acetylene, CH triple bond CH, on treating with water in presence of mercuric sulfate in acidic medium. So water is added across carbon to carbon double bond that leads to give intermediate compound vinyl alcohol. And this alcohol, vinyl alcohol, undergo intramolecular rearrangement, or it's also called as tautomerism. That gives CH3, CHO, aldehyde is formed. Okay. Now, when you go for other alkynes other than acetylene, on treating with water in presence of mercuric sulfate as a catalyst and in acidic medium, okay, addition of water takes place, and during addition it follows Markovnikov's rule. Intermediate compound is formed, and this intermediate compound, it undergoes intramolecular rearrangement to give ketone. It is about conversion of alkynes to aldehydes and ketone. Now, next method is reductive ozonolysis, starting from alkene, but reductive ozonolysis, where ozonolysis is carried out in the presence of zinc and water. First step, addition of ozone takes place in ether medium, that gives ozonite. After the formation of ozonite, it is treated with zinc, and zinc that controls the formation of hydrogen peroxide. Hydrogen peroxide, if it is formed, that oxidizes aldehydes or ketones to carboxylic acid. So this kind of ozonolysis is called as reductive ozonolysis. See, from alkene, reductive ozonolysis. Now, if we take simple alkene without any branching, on ozonolysis, R, CH, double bond CH, R, on ozonolysis, followed by hydrolysis in presence of zinc. It gives 2 moles of aldehyde. Say, during ozonolysis, this bond cleaves and oxygen is added to know the carbonyl compound. Directly we can write. Otherwise, in the first step, ozonide is formed. Ozonide on hydrolysis gives aldehyde. Now, when you consider this alkene, CH3, CH double bond, CH2, on ozonolysis, the product formed is, say, this bond cleaves, add oxygen atom for both the parts, that gives ethanol and methanol, Now, if we take branched alkene, where branching is observed, the carbon atom involved in double bond, R, C, R, double bond, R, C, R. So this on ozonolysis. See, this bond cleaves, that gives ketone, R, CO, R, ketone is formed. So example, CH3, C, CH3, double bond, CH3, CCH3, CH3, 2,3 dimethyl 2-butene. On ozonolysis, that gives 2 moles of propanol, acetone, propanol is formed. Okay. It is about the conversion of alkenes to aldehydes and ketones by reductive ozonolysis. Next method, from calcium salts of fatty acids. The method is dry distillation. From calcium salts of fatty acids. No. So in the preparation of aldehyde, a mixture of calcium salt of suitable carboxylic acid and calcium salt of formic acid is taken. RCOO twice Ca and HCOO twice Ca. On dry distillation, it gives aldehyde R, CHO aldehyde and CaCO3. So whenever we take calcium formate, that gives aldehyde. That means this CHO group is from this part, calcium formate. We'll take one example in this. Calcium acetate, CH3, COO, twice Ca. When it reacts with calcium formate, on dry distillation, say, instead of R, what you write CH3. So instead of R, you write CH3. It gives which compound? Ethanol, acetaldehyde is formed. Now in the preparation of ketones, a mixture of calcium salt of suitable carboxylic acid and calcium acetate. On dry distillation, it gives ketone. Ketone is formed. Byproduct is calcium carbonate. So in the preparation of ketones, you have to take calcium acetate. So this CH3CO group is from calcium acetate. Now, we'll go for one example. Calcium benzoate, C6H5, COO, twice Ca, calcium benzoate. When it reacts with calcium acetate. Now, instead of R, C6H5. So it gives aromatic ketone, C6H5, COCH3. Acetophenone is formed. If we take only calcium acetate, on dry distillation, that gives acetone, propanol. Okay. This is about the preparation of aldehydes and ketones from calcium salts of fatty acids. Next, about hydrolysis reaction. In hydrolysis process, dihalides are used, dihalides. Geminal dihalides are used, where two halogens are attached to same carbon atom. Hydrolysis process. Hydrolysis. Using geminal dihalides. Geminal dihalides. So, in the preparation of aldehydes, geminal dihalides of the type terminal, where two halogen atoms are attached to terminal carbon atom. Terminal geminal dihalides are taken. See, R, CH(X2). Okay. On hydrolysis, that gives R, CH(OH) twice. The compound containing more than one OH group linked to same carbon atom is unstable. Therefore, it attains stability by losing water. So, it becomes RCHO. Byproduct is water. We'll take one example, CH3, CHCl2. On hydrolysis, it gives intermediate compound CH3, CHOH twice. Then it gives CH3CHO and byproduct is water. So this is in the preparation of aldehyde. In the preparation of ketones, geminal dihalide, but it should be non-terminal. R, C, X2, R. On hydrolysis, that gives R, C, OH. Two halogen atoms are replaced by OH group. And this compound is unstable compound. So on heating, it loses a molecular water to give ketone. CH3, C, Cl, CH3, 2,2 dichloropropane. On hydrolysis, it gives CH3, C, OH and CH3. Then on heating, that gives propanol CH3, CO, CH3 and byproduct is water. It's about hydrolysis process. Now, next from Grignard reagent. Okay. In the preparation of aldehydes, Grignard reagent is treated with hydrogen cyanide or ester called ester of formic acid that gives aldehyde. Now, very important method from Grignard reagent. From Grignard reagent. Now, first one in the preparation of aldehydes. When Grignard reagent RMgX reacts with hydrogen cyanide in ether medium. First it gives an intermediate compound. MgX goes to nitrogen, R goes to carbon, HCr, double bond, N, MgX. This compound on hydrolysis, this part is eliminated and replaced by oxygen and it forms aldehyde. And byproducts are ammonia, NH3 and hydroxy magnesium halide, Now you just observe this. This is an alkyl group. When you compare this Grignard reagent with product, number of carbon atom is increased by 1. Like this, you have to study the organic reactions. Now, if I consider methyl magnesium bromide, CH3, MgBr, on treating with hydrogen cyanide, what about the product? It gives CH3CHO, ethanol is formed. So directly, without writing any intermediate step, directly you can predict the product. If you take ethyl magnesium bromide, that gives propanol. Now, there is one more method in the preparation of aldehydes. Grignard reagent or MgX treated with ester of formic acid, Okay. Ethyl formate, very important reaction. MgX is added to oxygen, R is added to carbon. So it gives intermediate compound H, C2H5. Then this on hydrolysis. During hydrolysis, this bond is cleaved. Okay. Gives aldehyde, RCHO, and byproduct is ethanol plus hydroxy magnesium halide. Like this reaction takes place. So if you consider methyl magnesium bromide with ethyl formate, the product is ethanol. Next one, preparation of ketones. In the preparation of ketones, when Grignard reagent or MgX treated with alkyl cyanide in ether medium, it gives intermediate compound is formed. So after the formation of intermediate compound on hydrolysis, it gives ketone is formed. Byproducts are ammonia and hydroxy magnesium halide. So example, if you take methyl magnesium bromide with methyl cyanide, or it's also called as ethane nitrile. Okay. It gives which compound? CH3, CO and CH3. CO, CH3. Propanone is formed. In another method, ketone can be prepared when Grignard reagent is treated with RMGX. Grignard reagent treated with ester other than formic acid. We'll take ethyl acetate, CH3, CO, C2, O, C2H5, ethyl acetate. On treating in ether, that gives CH3, CO, MgX, R, O, C2H5. This intermediate compound is subjected to hydrolysis. This bond cleaves. So it gives CH3COR, ketone is formed. So when Grignard reagent treated with ester of acetic acid or ester other than formic acid, that gives intermediate compound on hydrolysis, that gives ketone. Okay. Next, about some of the special methods in the preparation of aldehydes and ketones. Starting from nitriles. This method is also called as Stephen's reduction, where alkyl cyanide nitrile is reduced with stannous chloride in presence of HCl. This provides a nascent hydrogen that gives imine, RCH, double bond, NH, imine is formed. After the formation of imine is subjected to hydrolysis to give aldehyde, and byproduct is ammonia. So this method is called as Stephen's reduction. So here if you take ethane nitrile, methyl cyanide called as ethane nitrile, that will end up with ethanol, CH3CHO. Next method in the preparation of ketone. Next we will move on to preparation of aromatic aldehyde. In the preparation of ketone, Fiedel-Crafts acylation reaction. So in Friedel-Crafts acylation reaction, benzene reacts with acetyl chloride in the presence of anhydrous aluminium chloride. It gives aromatic ketone called acetophenone. Okay. Next, about the preparation of aromatic aldehydes, like benzaldehyde. Now, so in the preparation of aromatic aldehydes, starting from toluene, there are three methods from toluene. The first method is called as Itard's reaction, where toluene is treated with chromyl chloride in presence of carbon disulfide or carbon tetrachloride. First it gives intermediate compound, a brown complex. Intermediate compound is formed. See. And this intermediate compound on hydrolysis, on heating, that gives benzaldehyde, C6H5CHO. So this reaction is called as Itard's reaction. In another method, toluene is subjected to oxidation using anhydride of chromic acid, CrO3, in the presence of acetic anhydride, CH3CO twice O, acetic anhydride, that gives intermediate compound. Now this intermediate compound on hydrolysis, it forms an unstable product, CH, OH, OH. And this unstable product attains stability by losing water, that forms a benzaldehyde. In one more method, toluene is subjected to chlorination. So chlorine is passed through boiling toluene, where side chain substitution takes place. First, let me write side chain substitution. Various product, benzyl chloride. Benzyl chloride further undergo chlorination to give benzyl chloride. Benzyl chloride further undergo chlorination to give benzochloride. All these products on hydrolysis gives different products. Now this benzyl chloride on hydrolysis, first it gives intermediate compound. Now I'll write like this, CHOH twice, unstable product. And this unstable product on heating loses a molecule of water to give stable compound, that is benzaldehyde. So this is about conversion of toluene to benzaldehyde. There is one more method where benzene is converted into benzaldehyde. From benzene. When benzene is treated with carbon monoxide and HCl in the presence of anhydrous aluminium chloride, here formylation takes place. Formyl group is added to benzene, that gives benzaldehyde. This reaction is called as Gattermann's-Koch reaction. In another method, benzene is treated with HCN in presence of HCl and anhydrous aluminium chloride. It gives a imine, CH double bond NH. Imine is formed. So after the formation of imine on hydrolysis, that gives benzaldehyde. Benzaldehyde is formed. This reaction is called as Gattermann's aldehyde synthesis. determines aldehyde synthesis. First one is determines Koch reaction. Next one is determines aldehyde synthesis. It's about conversion of benzene to benzaldehyde. Benzene to benzaldehyde. So these are the various methods in the preparation of aldehydes and ketones. Next, quickly moving on to isomerism. Isomerism. So aldehyde exhibit different types of isomerism, like structural isomerism. In structural isomerism, chain isomerism, and functional isomerism. So example for chain isomerism, CH3, CH2, CH2, CHO. With same formula, we can write one more compound. See. These two isomers differ in the carbon chain. Such isomerism is called as chain isomerism. Next one about functional isomerism. Here isomers differ in functional group. Functional isomerism. Higher aldehydes and ketone, they are functional isomers. If you take propanol, CH3, CH2, CHO, propanon, CH3, CO, CH3. Now, other than these two, there are some more examples. CH2, double bond, CH, CH2, OH, allyl alcohol. When you go for allyl alcohol, you can take ethers. Ether. Okay. There's one more ether. See. It's called as oxalane, and this is called epoxides, oxiranes. Okay. So these are examples for functional isomerism for aldehydes. Same way for ketones. Ketone exhibit chain isomerism, position isomerism. In position isomerism, there is change in the position of carbonyl group. Simple example, 2-pentanone and 3-pentanone. Then you can go for functional isomerism. These examples you can take. So this is about isomerism in aldehydes and ketones. Next about chemical properties. Now, so between aldehydes and ketones, aldehydes are more reactive than the ketones. Among the aldehydes, aliphatic aldehydes are more reactive than aromatic aldehydes. Among the aliphatic aldehyde, formaldehyde is the most reactive. Now, it's about the order of reactivity of carbonyl compound. Formaldehyde is most reactive. Then comes ethanol. Then comes propanol, CH3, CH2, CHO. Then acetone, CH3, CO, CH3. Then ethyl methyl ketone. Then we can go for substituted ketone, CCH3, CO, C, CH3 thrice. So as the branching increases, steric effect increases. That reduces the reactivity. So reactivity that depends on the inductive effect as well as steric factor. So ketones are less reactive than aldehyde. That is due to inductive effect as well as steric factor. Now, some of the example for the chemical properties of aldehydes and ketone due to carbonyl group. First about addition reaction. Reaction with hydrogen cyanide. Now, when carbonyl compounds reacts with hydrogen cyanide, initial attack is by nucleophile. That gives intermediate compound. And that intermediate compound in acidic medium, that gives cyanohydrin. Cyanohydrin is formed. Now, I'll take one example, ethanol, CH3, CHO. On treating with hydrogen cyanide, that gives CH3, C, OH, H and Cn. Now this compound is not example for addition reaction. This compound is subjected to acid hydrolysis that gives CH3, CHOH, COOH, very important compound. That compound is called as lactic acid. It was asked in many competitive examination that given this entire series, you have to identify the initial reactant or about the final product, and that is optically active compound, lactic acid. It rotates plane of polarized light to right hand side or left hand side. And ketones also undergo similar type of reaction. Next, reaction with sodium bisulfite. When aldehydes or ketones on treating with sodium bisulfite, it gives a crystalline precipitate of respective bisulfite. Sodium bisulfite, NaHSO3. It gives respective bisulfite. Here all aldehydes reacts with sodium bisulfite. Whereas in the case of ketone, only aliphatic ketone react with sodium bisulfite. Aromatic ketone like acetophenone, it fails to react with sodium bisulfite due to steric hindrance. Therefore, when acetophenone is treated with sodium bisulfite, there is no precipitation. Next, reaction of aldehydes and ketones with alcohol. When you take aldehydes, it reacts with monohydric alcohol in the presence of dry HCl gas. The first it gives hemiacetal. It gives a class of compound called hemiacetal. Hemiacetal further reacts with methyl alcohol, CH3OH. On treating with methyl alcohol, it gives a class of compound called acetal. It gives acetal. It's about reaction of aldehyde with methyl alcohol, monohydric alcohol. Now, similarly, ketones reacts with dihydric alcohol. It reacts with dihydric alcohol like ethylene glycol. Now, in presence of HCl, that gives cyclic ketal. It gives a product. The cyclic ketal is formed. Is an example for addition reaction of aldehydes and ketones. Next, very important reaction is reaction with the Grignard reagent. And carbonyl compound, the rate of the reactivity towards Grignard reagent is much faster when compared to other type of reagent. Now, the reaction with the Grignard reagent. Grignard's reagent. When aldehydes are treated with Grignard's reagent, that gives primary alcohols or secondary alcohol. That depends on the nature of the aldehyde taken. So when Grignard reagent RMGX reacts with formaldehyde, okay, followed by hydrolysis, that gives primary alcohol RCH2OH. When Grignard reagent reacts with aldehyde other than formaldehyde, that gives secondary alcohol. When Grignard reagent reacts with ketones in ether medium followed by hydrolysis, it gives tertiary alcohol. So these are examples for addition reaction. Next, about condensation reaction. So condensation reaction also due to the presence of carbonyl group. When aldehydes and ketones treated with derivatives of ammonia like hydrazine NH2, NH2, hydrazine. Phenylhydrazine, NH2, NH, C6H5, phenylhydrazine. Hydroxylamine, NH2, OH. Semicarbazide, NH2, NH, CO, NH2, semicarbazide. Another reagent is DNP, 2,4 dinitrophenylhydrazine, 2,4 dinitrophenylhydrazine, DNP. It is also called as Brady's reagent or Bosch's reagent. So what is Brady's reagent? DNP, 2,4 dinitrophenylhydrazine. Now look here. When these derivatives of ammonia are treated with aldehydes or ketones, water molecule is eliminated. Water molecule is eliminated to give respective compound. Hydrazine is converted into hydrazone. Phenylhydrazine is converted into phenylhydrazone. Hydroxylamine is converted into oxime. Semicarbazide is converted into semicarbazone. Then DNP is converted into 2,4 dinitrophenylhydrazone. So this is about condensation reaction. Condensation reaction. Next about oxidation reaction. Oxidation. When aldehydes are treated with strong oxidizing agent like acidified potassium dichromate or acidified potassium permanganate, aldehydes are converted into carboxylic acid. So aldehydes are also example for very good reducing agent. It exhibits reducing property because in aldehydes, hydrogen atom is directly attached to carbonyl carbon. So due to this hydrogen, aldehydes acts as a good reducing agent. So because of this nature, it is oxidized by mild oxidizing agent like Clemencens reagent. Reaction with Clemencens reagent. Clemencens reagent. When aldehydes treated with Clemencens reagent, Ag NH3 twice plus in alkaline medium, here's ionic reaction that gives carboxylate ion and black precipitate of silver or shining mirror of silver. Black precipitate silver or shining mirror of silver. Similarly, there is one more reagent called Fehling's reagent. Fehling's reagent. Fehling's reagent. Alkaline solution of copper sulfate in presence of sodium potassium tartarate, Rochelle salt. Color is blue. Aliphatic aldehydes on treating with Fehling's reagent. Okay. Actually, it is in the form of cupric oxide, CuO. Aldehyde reduces cupric oxide to cuprous oxide, Cu2O, cuprous oxide. Cupric ion is converted into cuprous ion. Here color is red, blue color changes to red precipitate. Okay. So these two are example for reducing property of aldehydes. Now, ketone, it fails to react with Fehling's reagent and Clemencens reagent. Therefore, it is used to distinguish between aldehydes and ketones. Ketones, since they are less reactive, undergo oxidation under drastic condition. So an unsymmetrical ketone is heated with strong oxidizing agent like concentrated nitric acid. During oxidation, it follows Pophov's rule. So according to Pophov's rule, when unsymmetrical ketone is oxidized with strong oxidizing agent like concentrated nitric acid, ketonic group stays with smaller alkyl group. So this part undergo oxidation to give acid and other part also undergo oxidation to give acid. So it gives 2 moles of carboxylic acid, CH3, COOH and CH3, CH2, COOH. This is according to Popov's rule. Now, one more very important oxidation reaction, that is using selenium oxide. So oxidation reaction is carried out in presence of selenium oxide. Here one thing you have to remember, when CH3 group is attached to carbonyl group, during oxidation CH3 group is converted into CHO group. Or if CH2 group is attached to carbonyl group, during oxidation it is converted into ketonic group. Now, so this is about oxidation in presence of selenium oxide, using selenium oxide. Now, we'll take this reaction. CH3 COH, ethanol. When ethanol is oxidized with selenium oxide, SeO2, selenium oxide. Now this group is converted into aldehyde group, so it gives CHO. This compound is called as glyoxal. It forms glyoxal. Similarly, in one more reaction, CH3, CH2, CO, CH3. On heating with selenium oxide. Now this CH2 group prefers than the CH3 group. Therefore, CH2 group is converted into ketonic group. It gives a diketone. Like this, oxidation takes place. Next, moving on to reduction reaction. There are different types of reduction reactions in aldehydes and ketones, and product that depends on the reducing agent. First, about Clemencens reduction. In Clemencens reduction, zinc amalgam is used in presence of concentrated HCl. I'll write general reaction. Any carbonyl compound, when reduced with zinc amalgam in presence of concentrated HCl, that provides a nascent hydrogen, and nascent hydrogen reduces carbonyl group to methylene group. That means aldehydes and ketones, when it's subjected to Clemencens reduction, that will end up with hydrocarbon, respective hydrocarbon. Next reaction is called as Wolff-Kishner's reduction. See, in Wolff-Kishner's reaction, where carbonyl compound is treated with hydrazine, NH2, hydrazine. That gives hydrazone, NH2, hydrazone. Then this compound is subjected to hydrolysis. So it gives methylene, liberating nitrogen. This reaction is called as Wolff-Kishner's reduction. Now in the case of acetone, bimolecular reduction takes place. Very important reaction, acetone. CH3, CO, CH3, bimolecular. When reduced with magnesium amalgam, okay, it gives CH3, C, CH3OH, C, CH3OH, CH3. Okay. This compound is called as pinacol. Pinacol on heating, that gives pinacolon. That rearrangement is called pinacolon rearrangement. So when acetone is treated with magnesium amalgam, that gives pinacol. Okay. So these are the important reduction reactions of aldehydes and ketones. Now, next about haloform reaction. In haloform reaction, you have to remember the type of reactant. Haloform reaction. This method is suitable for ethanol, CH3CHO, ethanol, and the compound which contains methyl group attached to ketone, methyl ketones. When these compounds treated with halogen in presence of sodium hydroxide, it gives halo form CHX3. So suppose if you take iodine here, that gives iodoform. If you take chlorine, that gives chloroform. But there should be CH3 group attached to the carbonyl group. Ethanol undergo iodoform ethanol, alcohol, because first ethanol undergo oxidation to give ethanol aldehyde, then that ethanol undergo this type of reaction. Okay. So this is about haloform reaction. The carbonyl compounds on treating with PCl5, phosphorus pentachloride, oxygen atom is replaced by chloro group and oxygen is removed in the form of phosphorus oxychloride. Similarly, carbonyl compound on treating with thionyl chloride, SOCl2. In this case also, oxygen atom is replaced by chloro group, liberating sulfur dioxide. Now, so this is about some of the common reactions of aldehydes and ketones. Now, next we will move on to special reactions of aldehydes and ketones. Special reaction. First one is about aldol condensation. So aldol condensation reaction is due to the presence of alpha hydrogen or acidic hydrogen. Example is ethanol, CH3CHO, ethanol. When aldehydes containing alpha hydrogen on treating with dilute base, it undergoes self-condensation to give CH3, CHOH, CH2, CHO, aldol. And aldol on heating, it loses a molecule of water to give alpha beta unsaturated aldehyde. And similar reaction also observed in the case of acetone, CH3, COCH3, acetone. It is treated with strong base barium hydro because ketone is less reactive. So it gives CH3, COH, CH3, CO, CH3. Okay. Here one CH2 is missing. Yeah, CH2. Diacetone alcohol is formed. After the formation diacetone alcohol, on heating it gives CH3, CH3, double bond CH, CO and CH3. Now, next about cross aldol condensation. Crossed aldol condensation. Now, when you take ethanol CH3CHO and propanol CH3COCH3 or propanol, this undergo crossed aldol condensation. Now, when crossed aldol condensation takes place, if you take two different aldehyde, that will end up with 4 products. That gives 4 products. Next about intramolecular aldol condensation. Within same molecule, intramolecular aldol condensation. Now, CH3, CO, CH2, CO and CH3. When this compound is treated with dilute base, the hydrogen from this, it goes to oxygen and this carbon atom is linked to the carbon atom. That leads to give pentagonal ring structure. First let me write pentagonal ring structure. Now, We'll fix the ketonic group here, CO. After CO, this is CH2, this group, CH2. Now this carbon atom is linked to this carbon atom. Now this is this carbon atom. Here, H goes to oxygen. This becomes OH. And it also contains CH3 group. 3-hydroxy-3-methyl cyclopentanone is formed. And this compound on heating loses a molecule of water. To give 3-methyl cyclo-2-pentanone. 3-methyl cyclo-2-pentanone is formed. So this is about intramolecular aldol reaction. Next about Kenizarose reaction. So Kenizarose reaction is a characteristic reaction of aldehyde without alpha hydrogen. Kenizarose reaction. Aldehyde without alpha hydrogen, like formaldehyde, benzaldehyde, etc. Now, when you consider formaldehyde on treating with strong solution of sodium hydroxide, it undergoes self-oxidation to give sodium formate and self-reduction to give methanol. So it is an example for disproportionation reaction. So when benzaldehyde C6H5CHO on treating with base concentrated solution, that gives C6H5COONA, sodium benzoate and benzyl alcohol. Next about crossed Kenizarose reaction. Now, in crossed Kenizarose reaction, benzaldehyde C6H5CHO reacts with formaldehyde in the presence of base, strong base, that gives sodium formate and benzyl alcohol. Now, about intramolecular Kenizarose reaction. Intramolecular Kenizarose reaction, if you consider glyoxal on treating with strong base, one part undergo reduction, that gives CH2OH, and other part undergo oxidation, that gives glycolic acid. Now, one of the external compound which contains alpha hydrogen, but it undergo Kenizarose reaction. CH3, CHO. There is alpha hydrogen, but this compound on treating with base, it undergo Kenizarose reaction. It gives CH3COONA and CH2OH. Acid and alcohol is formed. This compound is called as 2-methyl propanol. Due to plus-I effect exhibited by these two groups, CH3 group, it fails to undergo aldol condensation, but it undergo Kenizarose reaction, 2-methyl propanol. The next reaction is called as benzoin condensation and Perkins reaction. It's for aromatic aldehyde, benzaldehyde, benzoin condensation. So in benzoin condensation, benzaldehyde is refluxed with ethanolic solution of potassium cyanide, KCN. Ethanolic solution of potassium cyanide. Now, it gives, now I'll write the ring structure, benzene ring, C, OH, H, CO and benzene ring. Okay. This compound is called as benzoin. It's called as benzoin. Beta hydroxy aromatic ketone. Beta hydroxy aromatic ketone. Okay. Next reaction is Perkins reaction. Perkins reaction. Perkins reaction. In Perkins reaction, benzaldehyde is heated with acetic anhydride CH3 CO twice O in presence of sodium acetate. It gives cinnamic acid CH double bond CH COOH. Alpha beta unsaturated aromatic carboxylic acid. Alpha beta unsaturated aromatic carboxylic acid. So this is about special reactions of aldehydes and ketones. Now, one more reaction called Tischenko reaction. So in Tischenko reaction, aldehydes containing alpha hydrogen on treating with aluminium ethoxide. This aldehyde first gives acid and alcohol, acetic acid and ethyl alcohol. When acid reacts with alcohol, that gives ester CH3 COO C2H5 ethyl acetate. This reaction is called as Tischenko reaction. Now, some of the reaction of formaldehyde with ammonia. So when formaldehyde reacts with ammonia, HCHO reacts with ammonia, it gives hexamethylene tetramine. Hexamethylene tetramine is nothing but urotropine. It's called as urotropine. Urotropine on nitration, it forms an explosive called RDX. Now, similarly, acetone CH3 CO CH3. This reacts with ammonia. That gives a compound called diacetone ammonia. Diacetone ammonia is formed. Diacetone ammonia is formed. Okay. Next one, about the condensation reaction of acetone. Very important set of reaction, condensation reaction of acetone. Now, when two molecules of acetone CH3 COCH3, this reacts with dry HCl. It undergo condensation reaction. Water molecule is eliminated. CH3 double bond CH CO CH3. This compound is called as mesithyl oxide. It forms mesithyl oxide. Now, when 3 moles of acetone reacts with dry HCl, this undergo condensation. 2 molecules of water is eliminated. That gives CH3 CCH3 double bond CCH3, here double bond CH COCH3. This compound is called as furan. So next reaction is important, where 3 moles of acetone is treated with concentrated sulfuric acid. It gives a cyclic compound called mesitylene. cyclic compound called mesitylene, or 1,3,5 trimethylbenzene, mesitylene, or 1,3,5 trimethylbenzene. Next one, reaction of formaldehyde, polymerization reaction of formaldehyde and acetaldehyde, formaldehyde and acetaldehyde. About the polymerization reaction, Now, when formaldehyde is subjected to polymerization reaction, on evaporation, formaldehyde, HCHO, on evaporation, it polymerizes to give paraformaldehyde. So during polymerization, that gives a polymer called paraformaldehyde. Now in the next reaction, 3 moles of formaldehyde, just by keeping for some time, on keeping, it undergo polymerization to give a cyclic compound. That cyclic compound is called as trioxane. Okay. Cyclic compound is formed. The compound formed like this: CH2O, CH2O, CH2. Okay. It's called as a metaformaldehyde, or it's also called as trioxane. Trioxane is formed. When 6 molecules of formaldehyde on treating with barium hydroxide or calcium hydroxide, it gives glucose C6H12O6. So all these are polymerization reaction of formaldehyde. Next, the 2 important reactions of acetaldehyde. When 3 moles of acetaldehyde, CH3CHO, in presence of sulfuric acid, concentrated sulfuric acid, it forms a cyclic compound called metaldehyde. Is formed. Structure of metaldehyde. Similarly, when 4 moles of ethanol treated with concentrated sulfuric acid. Okay. So this compound is called paraldehyde. Next compound is called as a metaldehyde, where 4 moles of ethanol is taken. Now, so this is called as paraldehyde. Now, next one, it gives a cyclic compound CH3, CHO, CH, CH3, O, CH, CH3, O, CH, CH3, O. This compound is called as metaldehyde. It's called as metaldehyde. So this is about polymerization of aldehydes and ketones. Now, next about the carboxylic acids. Now, okay. RCOOH. If R is alkyl group, aliphatic carboxylic acid. If R is aryl group, that's called as aromatic carboxylic acid. Now, about the preparation of carboxylic acid, when primary alcohols is oxidized with acidified potassium dichromate, gives aldehyde. Aldehyde on further oxidation gives carboxylic acid. Second method, from nitriles are C triple bond N. On acid hydrolysis, cyano group is converted into carboxyl group. But during the reaction, the intermediate compound First it reacts with one molecule of water to give amide, RCONH to amide. Amide on further hydrolysis that gives carboxylic acid. Now, using trihalides. When trihalides are subjected to hydrolysis that gives intermediate compound, unstable compound. And this unstable compound loses water molecule to give carboxylic acid. Now, next about set of hydrolysis reaction. First one, acid hydrolysis of acid chloride. When acid chloride is subjected to hydrolysis that gives carboxylic acid. Then acid anhydrides on hydrolysis that gives carboxylic acid. Ester RCOO R dash on acid hydrolysis that gives carboxylic acid and alcohol. Carboxylic acid and alcohol. Okay. Now, similarly, you can go for amide. RCONH2 amide on hydrolysis in presence of acid that gives carboxylic acid. Now, here, ease of hydrolysis. Acid chloride is more reactive than the anhydride. Anhydride is more reactive than the ester, and least reactive towards hydrolysis is amide. Okay. This is about hydrolysis reaction. Now, next one, starting from Grignard reagent. When Grignard reagent reacts with dry ice or solid carbon dioxide in ether medium, first it gives intermediate compound. Intermediate compound is formed, and that intermediate compound on hydrolysis that gives carboxylic acid. Okay. So these are the different methods of preparation of carboxylic acid. Now, next, moving on to the chemical properties about acidic property. Now, so carboxylic acids are weakly acidic, or organic acids are weakly acidic in nature that dissociate to give carboxylate ion and proton or hydronium ion. Stabilization of carboxylate ion takes place due to resonance. Now, so acidic nature that depends on the factors like electron withdrawing group and electron releasing group. Electron withdrawing group, that's minus I effect, increases acidity of carboxylic acid. Okay. Plus I effect that decreases electron donating group or electron releasing group. Plus I effect decreases acidity of carboxylic acid. Now, we'll take some example for minus I effect. If you take chloroacetic acid and acetic acid, which is more acidic? Chloroacetic acid, because of chloro group, minus I group. So as the number of chloro group increases, acidic nature increases. Trichloroacetic acid, dichloroacetic acid and monochloroacetic acid. Trichloro is more acidic than the dichloro. Dichloro is more acidic than the monochloro. And it also depends on the position. When electron withdrawing group is closer to the carboxyl group, that is more acidic. As the distance between the carboxyl group and electron withdrawing group increases, acidity decreases. Now, electron releasing group plus I effect, plus I effect. When you compare formic acid and acetic acid, formic acid and acetic acid. Formic acid is more acidic because in plus I effect is observed in the case of acetic acid. Similarly, in the case of aromatic carboxylic acid, this is benzoic acid. Electron withdrawing group increases acidic nature and electron releasing group decreases acidic nature, and also it depends on the position of the electron releasing group and the electron withdrawing group. Now, so about the chemical properties of carboxylic acid. Now, carboxylic acid on treating with metal, acidic hydrogen atom is replaced by sodium, or on treating with base, it gives respective salt. Okay. Then on treating with phosphorus pentachloride, it gives acid chloride. On treating with alcohol, it undergoes esterification to give ester. Okay. Ester is formed. When carboxylic acids are reduced with HI in presence of red phosphorus, it gives hydrocarbon. Or reaction with ammonia, the product is amide, RCONH2, amide. On treating with phosphorus pentoxide, it gives anhydride. It gives a product called anhydride. So these are the reactions due to carboxyl group. Now, some of the special reactions of carboxylic acid. The first one is HVZ reaction. This reaction is due to the presence of alpha hydrogen atom or CH2COOH on treating with chlorine and red phosphorus. Alpha hydrogen atom is replaced by chloro group. Therefore, when acetic acid is subject to HVZ reaction, that gives monochloro, dichloro and trichloroethanoic acid. About the reaction of benzoic acid. Here Carboxyl group, it acts as a meta-directing group. Therefore, in electrophilic aromatic substitution, it gives only meta product. So when benzoic acid is subjected to nitration, that gives meta-nitrobenzoic acid. Chlorination, meta-chlorobenzoic acid. Now, next, moving on to formic acid, HCOOH. Now, this acts as a aldehyde based on structure as well as acid and aldehyde. So because of structural formula, the formic acid reduces Tollens reagent to give black precipitate silver. It reduces Fehling's reagent to give red precipitate cuprous oxide, and also it reduces alkaline solution of potassium permanganate. That is because of its structure. So it acts as a bifunctional compound and it gives all the reactions due to carboxyl group. One more important compound, that is salicylic acid. This exhibits properties of phenol as well as properties of acid. We'll go for the properties of phenol. When salicylic acid is treated with concentrated nitric acid, it gives picric acid. Or salicylic acid on treating with excess amount of bromine water, that gives white precipitate of 2,4,6 tribromophenol, where decarboxylation takes place. Now, one of the important reactions due to carboxyl group, when salicylic acid is treated with the methyl alcohol, it undergoes esterification to give methyl salicylate. And methyl salicylate has got smell of oil of wintergreen. When salicylic acid is heated with zinc, that gives benzoic acid. Benzoic acid is formed. When salicylic acid is heated with soda lime, that gives phenol. Phenol is formed. Okay. Salicylic acid reacts with acetyl chloride, CH3, COCl. Here phenolic group undergo reaction to give acetyl salicylic acid. Acetyl salicylic acid, nothing but aspirin. Okay. So this is about organic compound containing oxygen.